Good morning. I, Salim, Assistant Professor in Kite Group of Institutions, presenting you types of error. So, all measurements can be made without perfect accuracy. Degree of error must always be assumed in any measurement. In reality, no measurement can ever made with perfect accuracy or 100% accuracy. It is important to find that actual accuracy and different types of error can be occurred in measuring instruments or in measurement system. Errors may arise from different sources and usually classified as follow. First, gross error, then systematic error. Systematic error is also divided into instrumental error, which is also divided into inherent shortcomings of instruments, misuse of instruments, loading effects, then environmental errors, observational errors, and random errors. Gross errors. First, the main source of gross error in human mistakes is reading or using instruments and in recording and calculating measured quantity. As long as human beings are involved and they may grossly misread the scale reading, then definitely some gross error will be occurred in measurement or in measured value. For example, due to an oversight, experimenter may read the temperature as 22.7 degrees Celsius while the actual reading may be 32.70 degrees Celsius. He may transpose the reading while recording. For example, he may read 16.7 degrees Celsius and record 27.6 degrees Celsius as an alternative. The complete elimination of gross error may be impossible. One should try to predict and correct them. Some gross errors are easily identified, while others may be very difficult to detect. Gross errors can be avoided by using the following two ways. First, great care should be taken in reading and recording the data. 2, 3 and even more readings should be taken for the quantity being measured by using different experiments and different reading points to avoid rereading with same error. So, it is suitable to take a large number of readings as a close agreement between readings assures that no gross error has been occurred in measurement system or measured values. Then we have systematic error. Again, it is divided into three parts. So, first we have instrumental errors. Instrumental errors, these errors arise due to following reasons: due to inherent shortcomings, due to misuse, and due to loading effect. So, first, inherent shortcomings. These errors are inherent in instrument because of their mechanical structure due to construction, calibration, or operation of the instruments or measuring device. These errors may cause the instrument to read too low or too high. For example, if the spring of a permanent magnet instrument has become weak, so the instrument will always read high. Error may be caused because of friction, hysteresis, and even gear backlash. Elimination or reduction method for these type of error. The instrument may be recalibrated carefully at different time of instance. The procedure of measurement must be carefully planned. Substitution method or calibration against standards may be used for this purpose. Correction factors should be applied after determining the instrumental errors. Then misuse of instruments. In some cases, the error are occurred in measurement system due to the fault of the operator than that of the instrument. Means it is a human error. A good instrument used in an unintelligently way may give wrong results. Example, misuse of instruments may be failure to do zero adjustment of the instrument, poor initial adjustments using leads to too high a resistance, and ill practice of instrument beyond the manufacturer's instructions and specifications. These are basically human errors. Then loading effects. The error committed by loading effect due to improper use of an instrument for measurement work. In measurement system, loading effects are identified and corrections should be made, or more suitable instruments can be used. Example, a well calibrated voltmeter may give a misleading or false reading when connected across a high resistance circuit. This is due to loading effect. The same voltmeter when connected across a low resistance circuit may give more reliable reading. In this example, voltmeter has a loading effect on the circuit, alternating the actual circuit conditions by measurement process. So errors caused by loading effect of the meter can be avoided by using them intelligently. Then we have environmental errors. Environmental errors occur due to external experimental conditions of the instrument, such as effect of temperature, pressure, humidity, dust, vibration, external magnetic fields, electrostatic fields, etc. Elimination or reduction methods of these undesirable errors are: first, arrangements should be made to keep the conditions as near as constant as possible. Example, temperature can be kept constant by keeping the instrument in the temperature controlled region. The device which is used against these environmental effects, we can use these. Then example, variation in resistance with temperature can be minimized by using very low resistance temperature coefficient of resistive material. Employing techniques which eliminate the effect of these disturbances, for example, the effect of humidity, dust, etc., can be entirely eliminated by tightly sealing the equipment. Then the external or electrostatic effects can be eliminated by using magnetic or electrostatic shield on the instrument. These are the reduction methods of environmental errors. Then we have observational error. There are many sources of observational error. As example, the pointer of the voltmeter rests slightly above the surface of the scale. Thus, an error on account of parallax will be acquired unless the line of vision of the observer is exactly above the pointer. The observational errors are also occurs due to involvement of human factors. For example, there are observational errors in instruments involving timing of an event. Different observer may produce different results, especially when sound and light measurements are involved. The complete elimination of this type of error can be achieved by using digital display at the output level. Then we have random errors. These errors occur due to unknown causes and are observed when the magnitude and polarity of a measurement fluctuate in changeable or random manner. The quantity being measured is affected by many happenings or disturbances and ambient influence about which we are unaware, are lumped together and called as random or residual error. The error caused by these disturbances are called random errors. Since the error remains even after the systematic error have been taken care, those errors are called residual errors. Random errors cannot normally be predicted or corrected, but they can be minimized by skilled observer and using a well maintained quality instrument. Then Here are the sources of error. First, insufficient knowledge of process parameter and design condition, poor design, change in process parameter, irregularities, upsets or disturbances, poor maintenance, certain design limitations, error caused by people who operate the instrument or equipment. These are the sources of error. Here are some other errors like relative error, fractional error, percentage of error or absolute error. This is all about types of error introduced or produced in a system or a measurement system. Thank you.